active. That's the whole idea. But the device here, which we're going to use today, is the Low-Pi 4. And there is a couple of different devices from PiCom. And this is not the most expensive one. There is one, I can show you here. It looks exactly the same when you just look at it, but this one, I see that it's a bit blurry. But they have a device called Wi-Fi as well. And the difference with this one is that I can actually put a SIM card in here. So this is not the device that you have, but I'm just saying that there are different devices. They also have a device which looks the same, but which doesn't have the LoRa and Sigfox protocol, but only Wi-Fi and Bluetooth. And then they call it Wi-Fi. That's the cheapest one. And today, you will most likely only be able to run your device on Wi-Fi. And why is that? Yeah, because the LoRa or Sigfox, I'm pretty sure most of you won't have a reception. And just to tell you about what these different radios are, Wi-Fi is, well, wireless communication, what we use it in our mobile phones, our computers, or TVs, everything. That's pretty much the standard for internet wireless communication. But the Wi-Fi protocol, it's in relative, it's very power hungry. So when I'm talking about power hungry, when we want to run something on battery, Wi-Fi might consume 100, 200 milliamps. And if you remember from the presentation we had last week with Barnacle, Wi-Fi is really not the way to go. And when we're talking about IoT devices, there are a lot of IoT devices which uses Wi-Fi. You can find smart scales, fridges, your freezer might be connected. And well, it is an IoT device per definition, and they might use the Wi-Fi protocol. But if you want to create something that is better operated, Wi-Fi is likely not the best way to go because it uses too much power. But if you want to transmit data, much more, video data or high resolution data, then Wi-Fi might be the way to go anyway. They have Bluetooth as well. We're not going to use that today, but they have it. And then what's most interesting about this device is that it's equipped with LoRa and Sigfox. LoRa and Sigfox are pretty much the same technology. LoRa is long range. It stands for long range. That's LoRa. But it's often called, when you talk about this, it's often called LoRaWAN, which is a subset with the long range wide area network. And the difference with long range wide area network and Wi-Fi is obviously they're different technologies. There's both still, the similarities is that they are both wireless, obviously. But LoRa is operating on a lower frequency. So LoRa is operating in about 800 megahertz. Wi-Fi is 2.4 gigahertz or 5 gigahertz. And higher frequency means lower range, and lower frequency, longer range. But the disadvantage with lower frequency is that you can transmit lower bandwidth. So the LoRa protocol, in theory, you can send the data about 15 kilometers. That's if you have an open range of sites, but it's much longer than Wi-Fi. So 10 kilometers shouldn't be a problem. And Sigfox is also a long-range IoT protocol, but which operates at the same frequency as LoRa, but they use a different technology for instead. LoRa is using a different modulation than Sigfox is, but it's more or less the same. They use the same chip and everything, and they operate in the same frequency region, but they modulate the signal in different ways. Sigfox is a company, and so you actually have to pay for using their services. In all these devices which you have, there is a 1-year subscription-free use of the Sigfox network. So you might get reception on that. What you have here is the antenna, and that's the LoRa and Sigfox antenna. It's a pretty bulky antenna. You connect it on the top. Let's see, it can be a bit tricky to push. On the top here, you can see the text here, and this antenna should go here. And how can you find that information? Yeah, good question. You find all the information online, and I'm going to share my screen instead of, let's see, share screen. Okay, I hope you can see my screen now. And just to give you an introduction of where you can find all the documentation. And it's as simple as you just write PyCom documentation in the Google search bar, and you will quickly end up at the PyCom documentation site. If you want the exact address, I'll put that in the chat window. If I just find it. Which I don't. Where do I do that? Sorry for this. Chat. Okay. It seems that I can't find the chat window. There it is. Okay. Okay, and I sent the link for this PyCom documentation. And I think it's a good idea that you open up that in a browser right away. So you have that homepage open. You might see everything on my screen now, so I hope it's not too messy. There is also a GitHub, which I've already, you might already be aware of this GitHub page. I created one for this course, and you find it under GitHub, and then my GitHub handle, FRAHLG, so it's a combination of my name, and MECH 550N, and there is a folder which is called IoT Workshop. There are some basic code examples, code snippets, which we're going to look at, which you can find there. Most of these you can find also in different versions online on other repositories. If you just Google around, so you will find a lot. And okay, where to start? As I'm recording this now, I will try to make it as quick as possible because you might go back. My recommendation is that you start with an IDE called Atom. You download that one. You might also use Visual Studio Code. They are very much the same. Visual Studio Code is Microsoft's IDE code editor, and Atom is developed by a team behind a GitHub team. Atom is open source, Visual Studio Code is not. They are very much similar so it's just a matter of taste. My taste is Atom. You don't have to choose the same as me, but Atom works very well. What you want to do directly after you have installed Atom is that you want to go into the preferences and then go into packages, and then you search for a package called PyMaker. And PyMaker is a package which we will use to communicate with the PyCon board. So this is a way of making the development much easier. So what Atom actually is, it's like a glorified text editor. That's what it is. And what we're going to do is write code, but the code is actually just a text file with Python code. So what this package helps us with is to help us to make it easy to upload and download code from the board. That's more or less it. And the big difference with these PyCom devices, if you compare that with an Arduino, which many of you likely have some kind of experience with, is that an Arduino, you write your code in the Arduino IDE, and then the code, well, obviously it's C code, and then it compiles the code on your computer, and you flash the firmware up to the Arduino. So the compiling of the code is done on your computer to the computer code. But in the PyCom device, it's already a Python interpreter on board. So what we're doing is we're keeping it at a high level programming language all the time, and no compiling is done. So the compiling is, you never compile it, because the Python interpreter automatically compiles the code into machine code when you run the Python file. And that's the neat thing about Python, is that it's pretty easy to understand the language. And this is the same language which we used in the data analysis. And as you see now, I just connected my board to the USB. Some of you might, I'm just saying that some of you might have problems with this. At least that's what I've experienced since before in previous workshops, is that if you run a Windows computer, you might have problems with drivers, but I can't give like an overall solution to anyone. You have to see what you can do about that yourself. And if you run a Linux computer, well, you might have some problems, but hopefully it will work. But that's like, it should work for 99% of you right away, just plugging in the USB connector, and it should, after you have downloaded Atom and you have the PyMaker plugin, you should get the terminal down here. And just to show that now I have the terminal down here, if I just write 1 + 1 and press enter, what I'm doing now is that I'm executing code on my Python board.
One question.
Yes.
Could you first explain us how to connect the things together?
Yeah, absolutely.
Because we are just in between. Just connected the antenna and the rest.
I'm going to change camera, and now you can see. Now you can see my hands. Yeah. So the antenna, actually, in this at this moment, you can skip the antenna. You can take that as the next part, but the antenna is supposed to go if you see the text here, and it might be too small, but now you can read the text. The LoRa antenna should go in the, if you're reading the text on the right, in the right direction, the LoRa antenna should go in the top left place. And it's just clicking it to position. If you don't have the LoRa antenna attached, don't worry. You obviously you will never probably ever get a signal, but in this case you will most likely run on Wi-Fi anyway. So that's why I'm saying that it might not be the first thing you want to do anyway. The USB cable, well, that's easy. It just fits in one end. You can't do it any wrong. And then obviously you put that in your computer. And the PyCom device, if you connect this the other way around, then, well, obviously it won't work. In my experience, you won't destroy anything, but the text should be in the same direction. And then it should be right. I didn't mention that, but at the expansion board, there is also an SD card reader. So you could use this as a logging device as well, even if it's not connected to anything and you want to log some data, you could save it to a SD card without sending it wirelessly. It says here, anyone have problems downloading PyMaker? Yeah, I don't know. It seems that no one has answered, but I'm just going to continue in showing where to start. I'm going to share the screen again. Yeah, so what we're actually doing is we are now communicating directly with the board over USB. And this should work out of the box for most of you. But just to start somewhere, I'm going to, it might be that many of you have a need of updating the firmware on the board. I am not sure about the version of the firmware on the board. So anyway, it can be a good thing to at least start checking that. And you need, if you're messing things up, or if you, well, I don't know, but if something happens, it might be a good thing to know how to flash a new firmware or update or downgrade the firmware on the board. So if you just Google PyCom firmware update, you can access, you'll get to their documentation page. But then they have their own tool for updating the firmware. And then it's just a matter of downloading that for whichever system you have. Obviously, I've already downloaded the PyCom firmware updater since before. So I'm starting that. And when you run the PyCom firmware updater, what we're going to do is that we're going to flash firmware on the board. So it's not a good idea to have Atom running at the same time, and it might interfere with trying to keep that USB port open for communicating with the board at the same time as you're trying to flash the firmware. This is how that program looks like, PyCom firmware update. And now it says, please close Atom, Visual Studio Code, or another program. I don't think any of you should have to update the expansion board. I hope not. But if you run into some kind of problems, the expansion board has a firmware as well, which can be updated. But don't worry about that. I don't think any of you should. In my experience, they should be updated with the newest firmware.
Professor,
Yes.
after downloading the Atom, what are we supposed to do? Do we open a project?
At this moment, you don't really have to do anything. We'll just, but what we're going to do is, yeah, we're going to open a project or create a project, upload that to the board, and then hopefully we'll get something running. That's the plan.
All right.
But I'll go through quickly here. If you don't get things to work right way just during this session, well, hopefully we can just follow up and let's see, chat there. Unable to download PyMaker. Okay, I don't have a solution to that right away. Hopefully it has to do with something on your computer or the servers are down. Well, I don't know. Has everyone the same problem, or is it just a couple of you that can't download PyMaker?
Frederick, I have a question.
Okay, I uninstalled it and tried again and it just worked. Okay. There is, if you have a Windows computer, I know that you need to have, it might be that you need to install Node JavaScript on your computer, but it should flag for that. And if that's the case, you go to Node.js. Because the PyMaker plugin and Atom runs on JavaScript. So this might be a solution if it doesn't work at all. But
Frederick, I have a question.
Yeah.
When I'm trying to upgrade PyComp, it is asking me select your board.
Yeah. And if you read on the board,
yeah, okay.
You can see that it's a low Pi 4.
Okay.
So it's a good question. What happens if you try to flash it with the wrong firmware? Like, I don't know. You might brick it. I'm not sure. But it's a low Pi 4, what you have here. And then if you, we have a couple of different alternatives here. I'm just going to, so here you have the port, and hopefully it will find automatically, depending on which, if you have a Mac, Linux, or Windows, but hopefully it will find itself automatically. You can flash from a local file. We won't do that today, but if you have a firmware, special firmware, you might try to do that. Then there are a couple of different firmwares we can use. There is one firmware called PyBytes, and that is connected to their own platform. So PyCom has their own backend platform. And there is one firmware called Legacy, which is just the core MicroPython platform, the firmware. PyBytes is, you can do whatever you can do in the Legacy firmware, you can do in PyBytes as well, but you get some additional libraries which you can use for communicating with the PyBytes platform. So I think it's easier that we start with the PyBytes for this moment, and then we're going to make the first example running in the PyBytes platform, which is their own platform. If you're going to build the project by yourself, I'm not sure if that's the best solution. It might be one solution, but there are 50 or hundreds different choices you can make on which platforms you're going to send the data to. But in order to start somewhere and make it quick and easy, I suppose PyBytes is the best one. Now it's reading information about the board. File system, I think you probably already have FAT-FS or little fs. You don't have to change that one. It doesn't matter. You can make, you shouldn't be able, you shouldn't have to erase anything during the update, but it should be empty when you start, but well, just to make sure you can do that. And the LoRa region should be US 915. And actually shows the European Union for my board now, because I have a router here in my office which is set up for that frequency. But you should use the United States 950 megahertz. And now it's my low-pi is flashing, and what I'm doing now, you might not. It might not be something that you have to do. Obviously, you already have a firmware on the board, but this is just a good way of starting up, so you know that you have the newest firmware. When the PyCom is upgraded, you'll get a result screen, and you have a couple of codes here. You have the device ID, LoRa MAC, Sigfox ID, and Sigfox PAC. What I recommend is that you copy these just to an empty text document, which you can put on your desktop. We might be using these later on, depending on what we're going to do. And these numbers, well, you can get them by certain code snippets in the terminal. But when you're working with your device, and if you're going to register that on the Things Network server, or if you're going to send data via the Sigfox servers, you need to specify from which device you're sending this. And LoRa MAC, for instance, that's this code. It might be small for you now. That's the physical address of this device. So it's just as a Wi-Fi MAC address. It's a physical address. And the same thing with the device ID, Sigfox ID. The Sigfox PAC, that's actually a code which is updated when you register it to the network. So that exact code will only be usable for the first time you register your Sigfox device to the Sigfox network. The next time it will be something else. So it's an encryption key. And these keys are also used for the encryption. So it's not really something that you should share, but in this case, it doesn't really matter. We're not going to have any sensitive information. But this just saves some time. So it's just copy that information and put it in a text document, and you will find it easy later on. Okay. But now when you have flashed the device, you might try and see what happens if you just open. And now the device for me here is empty. It says connecting to this USB modem, and now it stands there just blinking. And just to see if something happens, if I press 1+1, yeah, it does work. And without going into the many details of MicroPython, but MicroPython, which is the programming language of this board, is Python. So this is Python, but MicroPython stands for, it's a subset of Python. You won't find all the functionality which you have in the big Python, but it's a reduced subset of functions. But the code is written in the same way, it functions in the same way, and most of the code is exactly the same. So if you're going to define a function or loops or make calculations of some kind, I would say that most of it is exactly the same. It's just that, so whatever you can write in Python, you most likely can write it in MicroPython as well.
Patrick, just a question.
Yeah.
How do we, I haven't installed this Visual Studio Code.
You haven't installed?
No, can you just tell me that?
What was your question? I didn't hear you.
When No, the the bar where you are writing the Python code, like.
Yes, yeah, the PyMaker plugin.
Yeah, the PyMaker
so
plugin.
if this is for Atom, and if you go into Atom and then Preferences and under Packages, and then if you just search for PyMaker, PyMaker, you will find it. Did you find it?
No, we are not able to find it.
No, it's a plugin, right? So it will be.
Yeah.
We have to install that, right?
Yeah, absolutely. And I think okay. Sorry, you have to go to the install.
Okay.
There is like one packages and one install. Okay, obviously I've already installed that one. That's why it shows up for me. But well, install a new package and then search for PyMaker. Then you should find it. And if you don't find it, well, I don't have a good solution right away. Try to close the program, open it again, try again. If it still doesn't work with Atom, try to download Visual Studio Code, and it works in the same way. The plugin is called the same, and you'll find it under plugins as well. Yeah.
Okay.
Okay, and all these small details, I'm sure you will be able to sort them out on your own later on. So I'll just keep going, and you can listen in, and then as it is recorded anyway, hopefully you can go back and see which steps. But
yeah, okay, okay, Frederick, we got it. Thanks.
Yeah, and just to say that once more is that all what I'm saying now, I'm going pretty quick, and I'm just skipping a lot of parts just to give you an insight on what you can do right away. But you'll find all documentation, and it's a lot of documentation, and the documentation is really good and well organized on the PyCom website. So my suggestion to you is that the first step to go is actually go into the documentation. They have, if you press getting started, setting up the hardware. Well, it's a pretty neat picture here on how to connect everything. You have pictures on, if I press the low pi 4 here, hardware setup, it's loading, then you can see, okay, here's where I connect the LoRa Sigfox antenna, for example.
Excuse me, Frederick.
Yeah.
In the setting up hardware section, okay, we connected, but some extra wire, that is 3-pin wire something. So male and female connectors. So like where to connect, it's not shown here.
No, that's the sensor, which we're going to connect later on. So
okay.
Step one is just to, well, we need a way to just see that we can communicate with the board. That's like part one. And if you can communicate with the board, well, then we have done that part. The next part is obviously to know how to program and upload a program. And when we have done that part, okay, then we have come so far. And then, well, a sensor would be nice to read some information from. And then we're directly into, well, what can we do with this, with this device? And you have one sensor, and the sensor that you have is a DHT11 sensor. So it's a temperature and humidity sensor. And
okay.
Yeah. So, and we're going to connect that. It will be pretty easy. So it's just a way of connecting that to your device. You have a plus and a minus. You're going to connect that to ground and to the 3.3 voltage. And then you have one output signal, which we're going to connect to any pin. It actually doesn't matter as long as it's a digital in and output pin. And then in the program, we're going to define which pin we have connected that sensor to, and collect that information. But then we're into the software. And after that, we'll obviously try to send that somewhere. And when I'm saying send, it's that, okay, we're going to send it over Wi-Fi to some server. And in this case, it will not be some server, it will be the PyBytes server. And hopefully we'll see that data end up in the PyBytes server. If we have come so far for this session, I'm super happy. So
one more thing, like there are also three different, I think, plug, three different positions to plug the antenna. I think anyone would be better, like, okay, right? For the antenna.
For antenna. No, any of them is not good. It should be exactly in this spot as you see here.
But
the antenna on the left lower part, that's the 433 megahertz antenna, and the upper left part is the 915 and 868 antenna. And if you use a Wi-Fi antenna or Bluetooth antenna, that's the lower right part. But it has a pretty good reception, Wi-Fi reception anyway. So you won't be needing that. I don't think so. Anyway, I don't have a Wi-Fi antenna. The Wi-Fi antenna is actually a bit shorter than the LoRa antenna. But yeah.
Okay, so for this time, there is no need to connect the antenna, right?
No, you don't. You can connect it, no problem. But I'm just saying right away that it probably won't work for the majority of you or any of you. I've been trying to get a LoRa connection when I was in the office at the campus, and there is a LoRa gateway out at the UBC campus, the Things Network gateway. But it was really shaky getting a connection when you were indoors because of the concrete walls. So I managed to get one, but well, if we rely on that for this session, it will probably not end up well for most of you. So it's easier that we all just stick to Wi-Fi, which hopefully will work for every one of you. So that's the plan. So if we were going to have a physical workshop, I would bring a LoRa router to that workshop so I could control the environment. So, but short answer to your question, don't worry about the antenna for now. If you connect it, okay, fine. Yeah, but it will work anyway. Okay, but so the documentation part, please read up on the documentation. I won't be filling in all the information. I'm just going to show you how it can be done. And then it might not be enough time that you can digest all information at this very moment. Okay, so now directly to the next part. If you have a connection to your device, that's a good start. Otherwise, we won't be able to upload code to the device. The next part is that I'm going to close this one. Is that you go into the PyBytes platform, and this is, you can find it, chat window, and I sent a link in the chat window. You have to register for an account. It doesn't cost anything, so just register whatever email or that you have. And when you have registered on their service, what you're doing now is that you're registering an account on their backend. And if we have flashed with their firmware, they are giving us an easy way of creating an IoT device in a development setting right away. So just a quick, what you can add here is you can add projects, and to these projects you can add devices. So I have one project, you can create as many as you want. And then the neat thing about this is that if you have a project, let's say that you have a temperature sensor and you want to have 10 different sensors spread out over a building or something like that, then you can have a project for that application, the temperature sensor, and then you can add the devices to that project. And if you come up with a new fancy idea that, okay, I want to add this new function to all my devices, they have a way of creating a new release which can be automatically distributed to all your devices at the same time, wirelessly. So you can do a lot of nice things with this platform, if you like. But you don't have to create a project for this. We only have to create a new device. And what you can do is add a device. You choose which device you have, and you have all low-pi 4, just pressing that button. And then it asks for enable networks. So what we're doing here is that we are creating a configuration, the basic configuration for the device already on the web portal. So a lot of the stuff about the communication and where to send the data is done on the web portal. And then you enable networks. This is which networks do you want the device to use. And you could press all of them, and then it can use all of them, of course. And if it loses Wi-Fi, then it can connect to LoRa. And if it loses LoRa, it will try to connect to Wi-Fi and Sigfox. And then you can also drag or drop them into which order you want them to work in. But let's keep Wi-Fi as the first one, and then press next. And it will give you just a name. It just picks a name, Prickly Secretary 4255. Yeah, choose that if you want. The Wi-Fi needs to be added, so you need to add your Wi-Fi device, the SSID of your Wi-Fi. And I can say right away that if you're sitting on campus or near the campus, if you're using the UBC network, UBC Secure or eduroam or any public network, you might have problem. It might not work, because if you have a network, a Wi-Fi network, which you need a certificate on your computer to use, which eduroam, for example, is, it won't work. It's the same thing as if you have a Raspberry Pi or any other kind of embedded device. That kind of network, unfortunately, will not work. So can you please repeat this step? So the add the device step. I can start from the beginning. You go into the PyBytes platform. You'll have to register an account. I'm aware of that it might go too fast now, so but I'll go through with it anyway. And then you go into a device, add via USB. That's the easiest thing, as we already have a connection to the board via USB. They have an app as well, actually an iPhone app, which you can use. I'll use Wi-Fi and LoRa in this case. Press next. Now I got a new name, Colm Screw 4809. The Wi-Fi network, I've already pre-configured mine, but you have to pre-configure yours. So just put in the whatever Wi-Fi you have, so the password for your Wi-Fi. And then you can choose between two LoRa servers if you chose that TTN server. The TTN server is the Things Network server. If you're within range of that server, that's an open long-range network, which you can find all over the world, in Europe and in the US. There is a lot of servers in many cities. There are a couple of gateways at the UBC campus. I'm living in South Canby. There is no network coverage where I live. There is no network coverage in North Vancouver, and I would guess there is no network coverage in the eastern or south part either. So, but if you live at a campus, you might be lucky to find the reception of a TTN server at the LoRa network.
Yeah. When I'm on enable network, so shall I tick Wi-Fi?
Yeah.
And then it is asking me that SSID.
Yeah, that's the name of your Wi-Fi.
Okay, okay.
So if you're in my case, the name of my Wi-Fi is Woods family. So you can put in additional. You can have a list of different Wi-Fis. Yeah. So that's where your Wi-Fi, where you're sitting now. And I can say right away that if you're sitting on an EduRoam, I don't think it will work. I'm almost certain it won't. At least I've never managed to do it. So, okay. But then when you have added your device, you'll come to a new picture here. Well, you can see that, okay, you have the device here. It says last connection, never connected. So this is just a placeholder at this moment. I just added a new device in their portal. And there is no firmware unknown. I haven't got any data or anything. What I need to do is provision this device. So I need to tell this device, which I have plugged into USB, how to communicate and connect to the application on the PyGates platform. You can do that in different ways. One way is that I can see that I have a activation token here, which I can use in the firmware update tool. I can also activate your device with the PyMaker plugin. And it says install PyMaker plugin into Atom or Visual Studio Code, connect your device to USB PyMaker, copy and paste this activation string into the PyMaker window. And I copy this one. Let's see if it works. Please wait while we try to connect to Woods family. Wi-Fi connection established. Activating device. Oh, yes. You can see now something happened. And if I look at this page, I can see now that I have lost connection 10 seconds ago. So what I did now was to activate the device. Now the device has a connection to this PyBytes platform using the PyBytes plugin. What you also can do, I can show you that as well. I'll close Atom. I'll open the PyCom firmware updater. This is just different ways to do it. And you can find more detailed steps if you read documentation, of course. And then I press this force update PyBytes registration. I just enable that one. I copy this code, paste it in here, continue. And then it's going to flash the firmware of my device once again. But at the same time, now when I I inputted this application ID, the firmware update token, it will also put a configuration file on the board, which tells the board to connect to the Woods family Wi-Fi network and also to the PyBytes server. So this is one very quick and easy way to do it. I'll open Atom again and see what happens. You can see here on the board, there is a small reset button in this end. There is actually reset buttons also on the expansion board. But if I press the reset button, I'm rebooting the device. That might be a good way of seeing that, okay, it seems to be working if you want to run your code from the beginning. And you can see here now that initialized watchdog for Wi-Fi and LTE connection, Wi-Fi connection established, and it's now connected to the PyBytes platform. So this is a start. I still can communicate with the board. What I also can do is, because it's now connected to Wi-Fi, I'm actually using the web interface of the PyBytes platform to send code directly to the device. So I could, even without using Atom, flash a new firmware to the board now, only using the web terminal. So I actually now working with the writing code directly on the device. So that's a possibility that you also can do. You can flash files and edit code in the web browser, which will be automatically uploaded to the device via Wi-Fi. So it's pretty cool. I would still vouch that the standard way is that you use the Atom editor, keep it local, keep it at your computer. And also, if you're going to use something else other than the PyBytes platform, you have no choice. How does this work? If you look at a PyCom device, you have one file, actually two files, standard files. So the board now is empty. So all of you have no program on your board. When the board starts, the only thing it does is that it says hello to, it connects to Wi-Fi and says hello to the PyBytes platform. That's only because you flashed it with the PyBytes firmware. Otherwise, it's not doing anything. It just starts up, and then it's just a prompt, a Python prompt. If we want the device to do something, well, we need to upload code to it, obviously. And the Arduino way would be that we flash a firmware, but now we only have to upload code, which means that, and this is the really nice thing about working with Python devices, the PyCom devices, is that if I want to try out something out, I can dynamically, I can try whatever I want in the terminal here and see what happens. I can send up a new program code, see what happens, does it work, does it not work, and it goes instant all the time. You don't have to compile and flash and compile and flash. So it's really fast and easy to work with. The device is, if you send up a file called boot.py, it always starts with that file first. So that's the boot file. So it automatically always starts with the boot file. In this case, I'm going to open up a project now called temp humidity. This is empty. You can find this project on the GitHub page. So that might be a good thing to just go into the GitHub page. You should not use this, the configuration file here. Please don't use that one, then it will mess up your configuration file if you download that one. I should. I'll just remove that right away. Okay, now it's gone. So you can just, what you need to find is the main.py file, this one. It's not many lines of code. And just to make it easy for you, I can put that in the chat window. Let's see. There's a link in the chat window now, which directly goes to the code snippet, which I'm going to show now. And when you're working with projects, I'm going to you can have different project folders open at the same time. So if you want to work with different projects, no problem. In this case, one project is enough. And what you're actually doing is to go up to the file menu, add project folder, and then you can just take any folder on your computer. So it's wherever you want to store your code, doesn't matter anything. Just take an empty folder. And when you have an empty folder, you have your project folder, and you will see it in the left side. You can minimize that, and you can have different tabs, etc., etc. Let's see how I can get that back. Okay. No, I'm not really sure how to do that. Okay, I found it. It was hidden. When you have your project folder, what happened now? Sorry for that. I think I pressed the stop share button. When you have your project folder open, you can create different files, and the only file that you need to create is a main.py file. That will be automatically run when you start your device. It's very, very simple. And without going through all the details, what I'm doing now is that I'm first importing time. I'm from machine import pin. What I'm doing in that case, I'm using a library called machine, which is a library for interacting with the pins on the device. And I'm only interested in the pin. Okay. And then I'm importing a library called DTH. That's for the sensor. And you can find it, it's already in the GitHub page. You will just need to copy that library, put it in the same directory, and you're good to go. It's that easy. And then I'm importing a thread. And thread is a function called threading, which means that you can run something in the background of your program. What I'm first creating is a class called TH, temperature humidity. I'm using the library which I imported here, DTH. Now I'm defining which pin I'm going to use. And I'm just going to quickly show you how to connect this one without new share. And now I think you can see my other camera. And it's pretty simple. You have the sensor here, and if you look closely at the sensor, you have a plus, an out, and a minus sign. That means that the plus sign goes to 3.3 voltage. You have 3.3 volt on 1, 2, 3, the third place here. It is possible to connect it to the V in as well, but then you get 5 volt instead, and this sensor isn't supposed to get 5 volt, so it might get hot, but it might work as well. V in is the voltage in, so what comes in from the USB port. And then the minus is, not a hard thing to know probably, but it's the GND, which stands for ground. And then the other one is pin 23. And that's it. It's just to connect these ones down here. And when you have done that, the sensor is connected. Then you need to communicate with the sensor. And that is done. Now I'm defining the pin. And I use the time function just to give it some time to communicate. This is communicating with a one-wire protocol, and it's a slow protocol. It's called one wire because you can operate it on one wire. Now you can see it's 3 wires, but you can actually use the same wire for the signal and the voltage. And you can find these Dallas sensors. I'm not sure this, you can see it here. This is a pretty neat sensor as well. They cost almost nothing. You can buy them 100s in bulk. It's a temperature sensor, digital temperature sensor. And you can probably buy, they were talking about cents. They also use the same one-wire protocol, and you can find a lot of sensors which use that. And it's a digital, it's a one-wire bus, so it's actually communicating on a bus. So you don't have to read out a voltage or a milliamp signal. You're actually communicating with something over a bus. But these can be connected in parallel on the same bus. So I could connect 50 temperature sensors on the same wire in parallel using this method. When I have the next step is just a sleep function, just to give it some time. And then I'm defining a function here, define send environment data. And this is just a loop. So what it's going to do is that it's going to, let's see, something in the chat. Can you repeat connecting sensor with board? Absolutely. I can share the screen, computer webcam again. Okay, now you can see the webcam. What you need to do is that we have the DHT sensor here. On this one, you have a plus, out, and a minus. And the plus is on the left side and the minus on the right side. And the signal that is in the middle. So you have 3 pins out from this sensor. I'm not sure, but it might be that.
Frederick,
yes.
Frederick, the temperature sensor for mine is it's not.
You have this one?
It's not connected to the circuit board, and then
no, I think there was one sensor without the circuit board.
Oh yeah.
So you have only this one, and then you have 4 pins instead of 3.
Yeah, that's right.
Yeah, and I have to Google that because I don't remember. I never do. Google DHT11, and then you have an image, and you will get the pins. That means that in your case, you do the exact, you do the same thing.
Just directly plug in.
Yeah, you plug it in. The circuit board here is not doing very much actually.
But I'm just wondering, it has 4.
Yeah, one of those is you don't even, one of those you don't use. So the 3rd pin is you don't connect anything to it.
Okay.
Yeah. Okay. So the 1st pin, if I hold it this way, but it's better, just Google DHT11 and you'll find an image with the pin out connectors. And the 3rd pin, this one, you won't be using that one at all. So this is the ground, this is the voltage, and that one is the signal. And then it should work.
Yeah, I just don't want to blow it out.
Yeah.
it's wrongly connected because it gets heated up and it's.
Yeah, and I think that the worst thing that could happen is that it gets a little bit hot and it doesn't cost many pennies to replace this sensor. So,
Okay.
But don't worry. Don't be afraid when you're doing this. Nothing can really happen. Well, you probably can destroy something, but don't worry. They're not that expensive. So.
Okay, thank you.
Okay, when you have connected this sensor, I'm going to stop that share and I'm going to share the screen again. And here you can see a picture of what I'm talking about. What we're doing in this function is that we're going to fetch the results, and this function which I created up here, th function, this has a read function. This is just for, sometimes it doesn't fetch because it's communicating over a bus. So that's why you have like while the result is valid. So if it doesn't get a valid result, no point of sending that data. And you have a time sleep function just to give it a little bit of time. You can play around with this. But what I'm doing then is that I'm using the PyBytes library, which is already built in, and I send a signal. This is what I'm actually going to, now I'm actually sending that signal. And before I can actually just copy and paste and write all the code, import time, from machine, import pin. I have to, and I can go through all this. I won't be able to do that because the library is not uploaded just yet. So if I write from DTH, it will give that no module name DTH. So what I'm going to do now is I'm going to upload this to the board. And you can see here that I only have one project open. So it's very easy. But if you have a couple of projects open, make sure that you have the right one selected here. And then you have upload project to device. And what I'm doing when I press upload project to device is that I'm just uploading these Python files to device. And it should go very fast. And then it's also booting the device and starting up again. Now you can see that, okay, it's connected to Wi-Fi, the PyByte library. Now it doesn't do very much. You can see it just standing there in a terminal. It looks the same. But it has actually been running this main.py function file has been run when it started now. But I don't have any print statements or anything, so it doesn't give any output. But what I could do now is that I could try out some of the functions. If I write th read, then I get a result object. Okay, that was not anything that I wanted. Okay, let's see. Th. So if I write th read and then the parenthesis, that means I call that function, and then that gives an object, and in that object there are, in this case, two different values, one temperature and one humidity. You can see in the code up there that you have the result object, which I define result, which is equal to th read, and then I send both the temperature and the humidity. And you can see now that in the terminal, I got an answer of 23, and that's, well, the temperature. So it makes sense. It could be 23 degrees in here. And if I'll take the sensor and put it in my hand, let's see what happens. I got some kind of error message here. Failed to connect. Probably Okay, it says 26 now. So okay, it seems to be working. I wouldn't trust this sensor, but at least it gives some indication of the temperature. And the humidity, that gives a percentage, so it's 48%. It should go up. Okay, 95%. Okay, but what I'm doing now is that this is every 30 seconds. You can see down here, thread, start new thread, send environmental data. And what this does is that this function, which you can see over here, it's running all the time in the background in its own thread. And if you look at this function, it loops all over and over and over again, but it sleeps for 30 seconds. So in reality, what it does is that it sends a signal. And this is just signal 1, signal 2. That's easy. I could write signal 100 if I have a lot of signals. And then what it sends is signal 1, and then the result temperature. But that's just a number, as I showed you down here. If we now look at the PyBytes platform, we should find it here. And I check signals here. And let's see. PyBytes. I should see 3 seconds ago, signals. I should see that signal here, but I can't see it. Not sure why. I have received data, so that seems okay. No undefined signals. Okay. I'm restarting it. And then it should work. And what I'm waiting for is that I want a signal from the device to end up in this portal here. Obviously, it doesn't. That shouldn't. Dummy signal here. Okay, I just needed to press refresh, obviously. Okay. But now you can see that, okay, I have signal 1, signal 2. So I have 2 signals coming in here. And the PyBytes platform doesn't know what to call these signals, so I could define the signals. And I know that signal 1 is the temp and unit Celsius. Signal 2 is the relative humidity and unit percentage. I can look at the data. Okay, as you see, I have gotten some data already. But now you can see that 4 minutes ago, I had 95%, 47, 95. So what I'm having now here is that I have a device that is transmitting data to a server on the internet. And the data in the PyBytes platform, it's logged for, it says 1 month. But I could connect and push this data further on. So I could connect this, I could make a webhook. I could connect it to a Google Cloud platform and save it in a database there, or an Amazon Web Service or Microsoft Azure. So I could do a lot of things, putting the data just in another place. Well, I'm not sure what to say more about this. You can create a new display and make line charts, etc., if you want to present your data. But just to be very clear about this, that this is the PyBytes platform. It's only what you can do in this platform. And if you have come so far that you have managed to present your data as I did now, well, you've come a far way, and it's just a matter of trying to find other ways of presenting the data. You could push the data to some other service. You don't even have to use the PyBytes platform. If you want to go the Things Network route, you can go to that route as well. Then you need to create an account in the Things Network, create an application, and then you'll receive the data in the Things Network portal. When you have the data on their backend, and that is instead of the PyBytes backend, you can push it to wherever you like. But this is a very easy way to get started. You can also say that, let's see.
Take one question.
Yeah.
Can we use this GPS for locating some position?
This is not equipped with GPS. So, but yes.
Like if we put a sensor.
Yeah, if you have a GPS sensor, no problem. No problem at all. You can buy directly from PyCom. They have a GPS board, so exactly the same setup as you have now, but instead of an expansion board, there is also a GPS on board. And then you can get obviously you can get the location as well.
Thank you.
Yeah, or you could buy a GPS sensor, which you connect in any way. I'm just going to show you. There are, perhaps I'll show with you share. There are also apps. This is an app called Cayenne, My Devices, which is also, it's an iPhone app, an Android app, which you can build. You can build what we did on the PyCom device now. We just wrote some small lines of code for reading some kind of sensor value. And this is only, you can do whatever you want. You can connect this device to a Modbus or a CAN or something like that, or you could have whatever sensor. It's just software. You can do, as I say, you can do whatever you like. It's just software, and there's a lot of libraries already out there. So it's just a matter of implementing those. Then you send the data to some other place. And that other place could also be a Cayenne My Devices. And you could build your own dashboard in a couple of clicks with an iPhone app. You could send it to the Google Cloud servers or Amazon, or there is limitless possibilities when you have your data sent to the cloud. And if you remember from the Barnacle presentation last week, he said that as long as you have it in the cloud, there are like no limits on what you can do. It's very easy to do whatever you like if you want to process the data or just do something. And also, obviously, you can send data the other way as well. Now we have just transmitted data from the device up to the cloud. But yeah, if it's connected to Wi-Fi, it's no problem of having a high communication in between. If you're running on the LoRa or Sigfox network, you need to be really aware of to keep the bytes small. So if you want to send something, send a byte or two. Don't send it too often, maybe once a minute, not every second, because these protocols they are not really a good use of high resolution data. If you use the Things network, you will be locked